Welcome to a J400 training, section 4. In this section we'll see how the adaptivity map works. Here you can see the map adaptivity page. Now map adaptivity is disabled, but if you have selected or guided one or the customer one during the auto calibration, you will arrive in this page with the already selected one of this. Now we will try the guided one. Okay, so now we are on petrol. As you see, these squares are changing colors, and the meaning of these squares is that there is some map in the ECU that detect the petrol injection times, and we call it samples, and as you see here, in this way are increasing RPM, and in this way it's increasing map. So it's important that for using this kind of adaptivity we have a not valvetronic car, for example. We need that the manifold absolute pressure is working in a normal way. So on idle we have 0.30, and when we are on full power we have 1 bar or above if we are talking about turbo cars. Okay, but aspirated one we stay, however, under 1 bar or so on. Here you see the cursor in the exact position. Here we are. So if I'm increasing, I'm on idle now. If I am increasing RPM, you see that this bar is moving. Okay, and we are changing the square. So as you see, it's changing color even here, and so even in this square we need to have different samples for every square, and the square will turn green. We need to have at least 8 green squares, even if it's better to have them all, but it's quite simple. And another thing is that you see a gray region here and here. The gray region are a region where adaptivity doesn't work, because it's maybe a region that doesn't need to be adapted, or a region, for example here, that is at full power. It's a region that usually the car have no lambda control on the mixture, so it works maybe with a pre-mapping, and the values of injection time that we read here are not useful for the map adaptivity. Take the rest of the samples. We need to get on the road. It's not a long travel, you will see, quite fast as sampling. You need just to have a long road to have a little bit of stability overall for the high power section. So we are sampling it in real time, so you can understand how fast it is. This should be enough, but for a more accurate sampling I will take the whole squares. If you want to have a more accurate sampling, you can even drive for a longer time, and the ECU will detect any other samples and will make an average from samples that you take before. So taking this sampling longer, it will not be a waste of time, but maybe you'll get an accurate sampling section. Okay, as you see here, phase 2, we have to acquire gas samples. So now we switch to gas. Okay, and as made before with petrol, we have to make the same way with gas. You can make the first row of squares here on idle. That is more simple, and it will take a very short time. Okay, and now we're going on the road. It is possible to enable this flag sound. It will make little sound when we are on a section that is sampleless, so the driver can keep an eye on the road, and with the sound he can detect if he is running in a place of the Adaptivity map that it's empty as samples, and so you can be more safe while driving. Now we have all samples, petrol and gas samples, and we are in phase 3, so we have enough gas and petrol samples, so we can make an automatic computation of the Adaptivity map. So we click here. Now you see petrol samples and gas samples turned to a darker color, because now are not so useful for us. We now need to see only the result map, is the thing we have to take a look to. Here you see that the graded region has changed, because when we made the auto calibration we see that the idle point is this. So due to the fact that the auto calibration get a good calibration and good mixture for idle, we can avoid to adapt here because it's not needed. And the other section you see here, there are some red zones and some brighter zones here. So red zones means that here we had a linear mixture, so map adaptivity had increased a little bit the mixture here to have a better mixture. And the light blue regions here are regions that have no samples, so a region that are not adapting in this moment. And otherwise this is not the case because we have a mainly red region, but while red means lean mixture, yellow colors mean rich mixture. Okay, so this is a pre-mapping that the software calculates checking the petrol and the gas samples. From this point now the ECU will continue to adapt itself, taking more and more gas samples while driving. Now we get back on the road. You will see that gas samples are still changing and still acquiring new samples. And while we continue to acquire samples, the result map will changing a little bit. So it's normal that you see that the gas samples are turning from green to red again, because the ECU is storing the information in the result map, and then it will erase the sample on gas for taking another one. If you have a condition that the gas samples map remains all green squares, it means that every region of the result map has been optimized for injection time, so practically you have the same injection time when you're on petrol as when you are on gas, but it's quite impossible to have a condition like this one. To check the difference in milliseconds that you have running on gas or running on petrol about injection timing, you can click here on show gap, and you will see in every single point how far you are from the optimal mixture. You will see that sometimes the red circles, it disappears, because we are running in a point that maybe we have no samples, or maybe we are taking it. While the red circle is in the green square, it means that we are in tolerance, so there is a very little difference from injection time from petrol to gas. While when the red circle go in the yellow bar, so it goes out from the green square, it means that we are a little bit far away, and the ECU will make some adjustment to the result map to make the time match. Okay, now we try the customer adaptivity. Now we enable it. Okay. So when we are in a customer adaptivity mode, we have a darker color here on petrol samples and gas samples, because we are not supposed to make the 9 squares as made with the guided one, but the ECU will check when the petrol samples are enough, and automatically will switch to gas. The meaning of this kind of adaptivity it is that the installer can make just an auto calibration and a little bit of checking, and then he can give the car to the customer, so he will drive the car on petrol until the ECU get enough samples, and then he will switch automatically to gas. So this is very useful in condition where the installer cannot drive the car by itself, maybe because he is alone, or maybe because he lives in a very trafficked area, or something like that. So in this case, if we try to switch to gas, you see here below that there is a different type of flashing light here, and you will see that we are still on petrol. Okay, so now we will drive. It will take longer, so this part will be fast forwarded, and because this must be a little bit accurate, because it's supposed to be done without the laptop connected, because it's not needed. And when we are on petrol, we had enough samples, the ECU will switch automatically to gas, and we will hear a beep sound from the switch. So now I'm starting to driving, and we will see how time it takes for having all the samples we need, and then we will switch to gas automatically. You can even make the idle accelerating, like done with the guided one, because it works maybe in the same way. So it is useful because it catches more samples and is quite accurate. So we can make it, and then we can go back to the road. Okay, now as you have heard, the switch has beeped, and you see that we are on gas now. Everything is running smoothly, so we had enough samples, and now we are adapting